Okay. All right. Thank you, everybody, for joining us today, and I certainly appreciate having everybody here, taking a little bit of time away from their very busy day. I know this is a crazy kind of day between there's a big SQL conference out on the west coast of the United States over in SQL called the PASS Conference, so I know a lot of my colleagues are enjoying themselves, or probably pretty early. It's 8 in the morning, so they're probably still sleeping or on their way into the conference, but big conference over there. Wish I was there, but glad I could help Pragmatic Works out and step in for and fill in for them when they needed some extra help on the webinars. As well, of course, obviously it's election day, as we've been talking about. So, but I'm glad that those 143 of you here could join us today, and going to be discussing some backup strategies. I'm actually decided to take. It's not going to be entirely about backup strategies. I'm going to actually kind of take a step backwards and start from a little bit more from the beginning and teach them some basic backup terminology and strategies and concepts, that kind of thing. And so it's going to start the conversation in more of a beginner slash novice slash intermediate kind of mode, and move it a little bit forward from there. If it's something that's already knowledgeable, if you already know about and you need to drop off, you want to drop off and say it's something you already know, certainly not going to hurt my feelings. So, but anyway, I wanted to warn you in advance that we're going to kind of start from the beginning, and we're going to move forward from there and talking about backups. So, we shall move forward. I had an idea that I was going to do the entire presentation in wingdings, but I decided it may be a little difficult. But anyway, this is the agenda right here. If you guys want to copy that down and translate that later, that's what we're going to do. Okay, so maybe that's not the best idea, so let's go ahead and do it in good old English. All right, so these are things that we're going to be talking about today in general. Okay, I'll go over a quick bio of myself and who I am, an overview of SQL backups and some of the concepts that are related to them. We're going to talk about the second most important part about backups, and that's restoring. We're going to play a little abbreviation game here with some of these terminologies right here. We're going to discuss some of the recovery models that are available in SQL Server in 2005, 8, 12, Express models, and how they are relative to your backup plans and your strategies, and what kind of backups you have to do based on the recovery model. We're going to talk about your system databases. A lot of times people talk about backing up, and they discuss what they're going to do with this user database and what schedule they're going to use for that user database, but don't necessarily address the system databases. So we'll talk about it for a couple minutes. We'll talk about compression, some of the ways that compression benefits you when you compress your backups, and some of the third-party tools, excuse me, and some of the native tools that you can use to compress your backups. We'll talk about what kinds of backup types there are. There are 6 or 7 different types of backups. Obviously, most people are familiar with your full backups and your log backups, but there are a couple other backups that are types that are very, very useful. We're going to talk about methods. Oops, I didn't mean to do that. How we're going to talk about methods. How you go about engaging your backup plans. And then, of course, well, it should probably be the other way around, but the planning of it first before you implement your methods. But anyway, we're going to talk about how you go about planning and how you go about coming about your backup plans. I'll take a real quick look at some system tables that are there, so you can go ahead and query and see what's going on with your server's backups. Real quick look at that. And as well, I'm going to show you a set of scripts that I use all the time and I think are absolutely wonderful, and I will share them with you, and we will move forward. This is about me, real quick page. I'm a DBA right now. I'm working as an independent contractor for a company based out of Tampa, but I live in Jacksonville, Florida. I'm moving to New York City this winter, eventually, but I am moving to New York City this winter. I've held roles as a DBA currently, obviously, and I've been a developer and a business analyst back in my career. I've been in Jacksonville for, like I said, almost 15 years now, almost 15 years now, and moving up north to follow the hurricanes, I guess. Unfortunately, it seems kind of odd to leave Florida to go to New York, and that's where all the bad weather and the hurricanes are, so go figure. These are my handles on Twitter, my website, that unfortunately I don't update anywhere near often enough. I would certainly love to have you join me as a professional contact if you would like to on LinkedIn. I don't know why this isn't blue like the rest of them. And if you're into photos and photographs and social networking with your photographs and your camera, I'd love to see what kind of stuff you do on Instagram. Obviously not business related, but I really enjoy Instagram, and if you do as well, feel free to look me up. Okay, real quick then. We'll get into the meat of what we're doing now. An overview of backups and SQL backups, and this actually obviously pertains to not just SQL Server, but all database systems. In the simplest terms, what's a backup? Well, again, I mean, I know this goes way back to the beginning, but obviously in the simplest terms, a backup is a copy of your database that is taken at a certain state at a certain particular point in time. This allows you, depending on the type of backup, it obviously allows you to return your database or return your server to a particular moment in time or to a particular status. If something goes wrong in your database, and we'll talk about some of the ways things can go wrong, and you do find that you have a need to return in time, unfortunately Control-Z or undo command doesn't work in an environment where you have commands coming in from all over the country, all over the world, saying update this row in this table and delete this row in this table and make this change to this table. With those things happening possibly thousands of times a second, the only way sometimes to revert back to a previous point in time is to say, okay, we have to stop where we are. We have to say we have a snapshot of a particular moment in time as of this moment in time, and we can go revert back to it. Now the question is, how far back is that moment in time, and how much data will you lose? If you have a corruption in your database right now, and you don't have a backup from 24 hours ago or 23.5 hours ago, you can see that you're going to lose a lot. Obviously, there are ways to mitigate that, and that's some of what we're going to talk about this morning. We obviously talked about some of the reasons, the important reasons to back up your databases. There are so many things that could go wrong just on a day-to-day basis, and if you've been DBA or been database professionals or IT professionals, they all will come up and they all will happen eventually. You can have the most stable system in the world, and then one day, as soon as you step out of the office to do something fun, that's when you get a corruption. So I mean, disks can go bad very easily. Hardware problems happen when you least expect it. You can also be the victim of a malicious damage. Somebody could sabotage you. Could be an unhappy employee. Could be somebody from the outside sabotaging you over the internet, inserting bad rows into your databases or pulling stuff out and making changes to your database. So there are malicious damage reasons that you could also want to revert back to a previous backup. User error is another big one right now. Hey, you have a new DBA or a new SQL professional in your company, or somebody who's been given just a little too many rights or permissions on a table and accidentally runs a delete statement without a where clause. Well, we've all seen it happen before, but what happens is instead of just deleting one or two rows of this very important 60,000 row table that contains all your company's records, they run the delete statement against the whole thing, and they take it away. So at that point, everybody panics and screams at that person, and then they go back to the DBA and say, okay, how soon can we get a backup in place so that we can have this table in full back there? Database corruption is another big reason that we back up our data. Not just SQL Server, and SQL Server is actually very good. The database corruption is a less and less of a concern these days as Microsoft does a better and better job of putting foolproofs into their software to prevent corruption, but it does happen. So database corruption, and obviously it does still happen, is the reason we still do our consistency checks on a regular basis. But database corruption does happen, and sometimes when it's found, the only way to go back is to restore from a backup. And then there are less evil, I shouldn't say evil, but there are less, there are reasons that you might want to back up a database that are normal. Obviously, for instance, if you want to copy a database and you want to move it over to a development environment, well, sometimes the easiest way to do that, there's several ways of doing that. You could use SSIS, you could use a attach methodology, but sometimes the easiest way of doing it, because it wraps it all in one nice little package, is to take a backup and move that backup across the network and restore it on your other server, on your development server or your QA server. There are ways of doing that, so it makes it nice and easy, and it doesn't even involve the backup chain, that kind of thing. So we'll go over that as well. Many reasons. What happens if you don't back up? Well, kind of already can surmise what happens if you don't back up. You just don't have the ability to be able to restore in these emergencies, in these kind of situations. People lose their jobs extremely quickly when one of their requirements is to make sure we can have our data, and then they don't have it. That's why the backup plans are so important. And I guess what an emergency, we kind of talked about that before when we were going through the reasons why you back up your SQL Server databases. And the other half, now, although this webinar is called Backup Strategies, Restoring, I don't have to convince anybody that restoring and knowing how to restore your databases is one of the most vital pieces in the puzzle. The ability to take up a nice clean backup and have a good plan means nothing if nobody has the ability to take one of these backup copies or these transaction logs or differentials and know what to do with them to get things back. And it's not just a question of one person. I mean, it's not a question of one person. Do we have, maybe this is a small organization and they do only have one database guy, one guy who fits the role of the DBA and the analyst and the developer. But eventually this guy or gal's got to take a vacation. So so there's going to be a backup plan. Somebody else needs to know how to restore these and what the plan is. And obviously, this is where documentation, good documentation comes into place. You write everything down, you get a plan, you write it all down, and say, okay, this person is the #1 person that's going to do these restores, and we're going to call this person this kind of place, and these are the methodologies that they're going to use to restore these databases. And then this person is going to be primarily responsible. But the plan also includes a backup person and perhaps even a backup to the backup person, a chain of people, so that this can be done and business can be restored and business can go back and go in a very timely manner, which is very important to the business, the most important thing to the business. They don't care about your vacation. They care about getting their database back up and their income rolling back in again. It's the most important thing. Don't lose your job over the fact that you went on vacation and didn't teach anybody to restore your database when you weren't there. And part of it is practicing. And you practice restoring and you practice this situation and that situation. What if this data center were out? What if it was back to this time? Or what if it was a minute before this backup was taken? How do I do this? You practice things. And it's not embarrassing to say I'm a DBA, I need to practice. That's part of being responsible and being part of it, being aware and being prepared for your job. And then you practice some more because then it is that important. And we partly talked about this, is like, how are you going to do it? Make sure that you put this down. You put this down in a documentation, in writing, in a Word document, and say, hey, listen, this is how we're going to do it. This is the process that we've decided. If this is what the situation is, well, then we're going to go ahead and restore these things in this order. If this is what the situation is, we're going to restore things in this order. So put that down, get it approved by the suits upstairs, and put it in a safe place where everybody knows where it is. And then practice and practice again, guys. Can't emphasize that enough. Okay, now we're going to play this is the part where the cool abbreviations are. I just thought this license plate was so cool. This sounds like my girlfriend Trish, exactly. She always wants people in front of her to move. So anyway, the cool abbreviation page. These are the 3 most commonly heard abbreviations when it comes to lots of abbreviations in SQL Server and in IT, Microsoft products, but these are the ones you're going to hear when referencing database and database backup strategies. The 2 most important thing are, first one, RTO, Recovery Time Objective. Pretty much what this means is how much time are you allowed to recover from an emergency. And I'm going to use the word emergency right now as just a generic term from going forward to refer to any of those things we talked about before: disk failure, malicious damage, user error, corruption, all those things. Excuse me. We'll use the term emergency from going forward here. So, how much time can be taken to recover from an emergency? The business, the important thing to realize about this is that this is not something that's defined by IT. It's not defined by your DBA, by you guys. It's defined by the management. This is defined by the business. The business will tell you, hey, listen, our objective is we cannot be down. We cannot be down for more than 10 minutes, otherwise we lose $100,000 in income. So your backup plans have to be designed in order to get us back up and going in 10 minutes, as quick as possible. company obviously like an Amazon or a company that does a lot of individual transactions, for instance, an online, retailer that counts on transactions coming in thousands and thousands at a time every single minute. They're down. Their databases are down for more than 10 minutes. They're losing huge amounts of income. And of course, they have shareholders that they're responsible to. So in that case, you orient your backup plans to get things up and going in the quickest time possible. And again, it's executed by IT, it's executed by the DBAs, but it's defined by the business and the business model. That also applies to RPO, our recovery point objective. This is asking us how much data can be lost when we want to recover from an emergency. So at what point do we have to, what is the largest amount of data that we can lose to be able to say, okay, well, we've done this. So this defines how often you take your backups. This is one of the things that defines how often you take your backups. If the business says, I cannot lose, no matter how long it takes you to get back up and going, we cannot lose more than 15 minutes worth of transactions at any one point. Well, then you've established your RPO. Again, this is, once again, exactly the same as RTO. This is defined by the business. The business is going to tell you, your IT guys, your DBAs, what your RPO is, how much data can we afford to lose. And then, of course, it is up to the IT folks to go ahead and implement that, execute their plans. So RTO and RPO both defined by the business, executed by the DBAs or the database team. And the third one that you'll hear sometimes, not as common, not as often, is, and you're gonna need to take into account, of course, is how often the data changes. This is actually really not defined by any individual, whether it's in business or in IT, but this is actually the business model that the organization is following. This is saying, okay, how often does this data change in this database? That'll go into a lot. That'll be a big factor in what sort of backup strategy you come up with. For instance, this is a database that only has processes that work overnight. Say it's a database that is an intermediate for a data warehouse, and the only thing that happens is at 3 o'clock in the morning, an IS package shovels some data in there, there's some manipulation, and the data is removed, or it's read from there, or it's a reporting database. Obviously, it still needs to be backed up, but all the main input and output to this database happens at 3 o'clock in the morning. Well, the data change rate during the middle part of the day is different from the data change rate for the end part of the day. So all these things you need to take into account. And we're going to get back to that example a little bit later too. Okay, moving on here. Recovery models. I thought this was kind of cool. I don't know if you can, hope you can see this in the GoToMeeting thing, but I thought this is a good recovery right here. Boom! And he's down. You really think, we're going to watch it one more time. You really think that right about here, he's a goner. He's going to be rolling down this hill, and that's that. But then right there, he hits the tire, and hits the gas, and he gets going down. Anyway, fine recovery. It'd be hard for you to be paying attention to what I'm saying now that this is on the screen, but whatever. 3 recovery models. The bulk of your databases, 99% of your databases probably are going to be in one of the top 2 recovery models, and most of them will probably be in the full recovery model. So, but I want to go through the three main recovery models real quick and let you know on how they affect your backup strategy. First of all, the full recovery model. Well, the full recovery model, the important thing to remember about the full recovery model is that the transaction log. Oh, it stopped. Nope. We'll try this again. In the full recovery model, the transaction logs, which obviously are logs that are taking note and recording every single transaction that goes on in a database, which allows you to go and say, hey, I want to restore up to this particular time, the last time I took a transaction log backup. In a full recovery model, the transaction logs are not truncated. They're not brought down to a small size, a small reasonable size, until the transaction log is backed up. So that being the case, or there's a full backup taken, of course. So that being the case, if you have a database which is in a full recovery model, then the log backups have to be taken. They must be taken. You don't have a choice in the matter, because what will happen is your transaction logs will continue to grow, and they continue to grow. You might have a 100 megabyte database, But if you've never scheduled a transaction log backup, well, then your transaction log is going to grow, and it's going to grow, and it's going to grow. One of the couple things is going to happen at that point. You're going to number one, obviously, is going to keep growing, so you're going to take a loss every time that transaction log file has to grow. But eventually, that drive that transaction log is on, if it's allowed to go unending, is going to fill. And of course, obviously, then you're going to have much more problems if that drive is, say, that drive is on the C drive, and you have Windows trying to operate on that drive. Or let's say you have it in its own dedicated drive, but it fills up completely to 100%. Well, then you have a database in read-only when you have users trying to use it. So, I'm not going to go into the benefits and the problems and stuff like that with the transaction log maintenance and stuff like that right now. But understand that if you do use the full recovery model, the transaction logs do need to be backed up all the time on a regular basis. The second recovery model is a simple. Now, in this recovery model that you set your database in, the transaction log truncates itself on a constant basis. So as transactions are committed, certain conditions are met on the database, the transaction log itself is truncated, even without a backup being taken of it. So this obviously says since the transaction log is being truncated on its own, and we cannot take backups of it. In this scenario, if we're in the simple recovery mode, the closest we can do is restore back to the last full backup, or possibly the last differential backup, because you can take differentials in the simple transaction mode. I'm in the simple recovery mode. Basically, in a nutshell, in the simple recovery mode, your RPO, your recovery point objective, is equal to your last full, your last diff. So you can't. Then something that the business will have to realize. If it's let's say it's a database that has hardly any transactions going in and out, it's just maybe every once in a while some rows are added to it a couple times a day. It's mostly holding archive data. Well, obviously, in that case, maybe the business can say, hey, the transaction log doesn't need to be backed up every hour like it does on our other production databases. So you switch this one over to the simple recovery mode. You do a full backup every night at that interval, and you're covered, and you're fine. The business understands the risks that, hey, if something should happen, the only thing we can do is go back to last night's full backup. In that case, it's just a payoff between overhead, and recovery time. The third and less often used recovery model is called bulk logged. It's very similar to the full recovery model, and I won't get into this too much, but what happens is it uses a concept called minimal logging during bulk operations. Again, I don't want to get into it too much because it's already half past now, but know that this is an option sometimes where developers will say, let's move it into the, if it's doing what happens is if there's lots of transactions, numerous transactions, like in the case of a data warehouse, it's going to play havoc on your transaction logs if a lot of them have to move in and out on a nightly basis. So a lot of times the developer or DBA will come up with a strategy that they turn a database over to the bulk log mode, do their bulk imports, and prevent the logs from growing and blowing up, and then bring it back over to the full mode again. So that's an option. Again, that's an advanced option, excuse me, but something that's certainly something that can be done, and there's lots of documentation out there about that. So, all right, if you've seen this white Jeep going down enough, one more time. Here we go. Ready? And he's out of there. All right, cool. Okay, the system databases. I mentioned earlier, quick. A lot of times, a lot of attention is paid to how you handle and what you do with your user databases, but not always. It's not always clear what happens and how often you have to back up your system databases. Only 4 of them, obviously. So really quickly, we'll go over each one. Master databases. The master database contains all your schema objects, all your database objects. So anytime that's going to be different, anytime there's a schema change or a database objects change, and is generally the best practice to go ahead and back this up once a day. Technically, if you don't do any schema changes or object changes, which would be very rare to me, but if you don't technically, then you don't necessarily need to put this back this up on a daily basis. It's usually easiest. It's relatively small, although master is probably going to be the largest of the 3 back-upable system databases. Still easiest. Most likely, in most operations, this is done on a daily basis. MSDB is the system database that keeps track of not just all your backup stuff, but all your agent, everything that has to do with scheduling for agents and for your jobs. Excuse me. This is generally this is going to be changed a lot, especially if you do want to backup, especially if you are performing backups within the system and not using a third-party tool. So all these backups are being registered in these MSDB tables. Again, something that is usually done on a daily basis, doesn't necessarily need to be done more often unless you're in a very, very high change environment. The model database is the one that probably makes the least amount of changes as possible. This, of course, is what just uses a generic blank template database that's used for when you create a new database. Some people like to make changes to the model so that when they create a new database, it goes ahead and creates them in that format. It gets changed very, very rarely, again, so it doesn't really need to be backed up that often. It's very small. It's an empty, quick database. It's actually just instructions for creating a new database. It's not really even the whole thing itself. It's actually just, so the size of it is very small. So go ahead and back this up on a daily basis as well, as long as you're doing the other two, but not necessarily needed, if that makes sense. TempDB. Well, TempDB, go ahead and try to back up your TempDB, and I'll tell you can't, because the TempDB is not a back-upable, and I'm going to make up words here, back-upable object. TempDB is something that is recreated every time you start your SQL server. If you, for whatever reason, have to restart your SQL service, obviously our transactions are kept and we maintain referential integrity and transactional consistency, but the TempDB is recreated from scratch, starting all over again. So obviously on an object that is treated as such, there's no sort of chain that could ever be recreated if it's an object that is destroyed and recreated. So for this very reason, the TempDB, and by its nature, you cannot back it up. No need to worry about including it in your backup plans. Compression. I thought this was a good example of compression. People, looks like an Asian subway and some people being pressed into the subway car. I think you may have to get used to this, so I'm living in New York City, but hopefully it won't be this bad. What do you need to know about compression? Well, obviously some of the obvious benefit of compression is its size savings. I mean, I'm not blowing anybody's mind with that statement right there. But if we have a database that is 150 gigabytes and it compresses down to 35 gigabytes, well then obviously you've saved 70% of your drive space. There are speed benefits as well, because sometimes compression can be quicker than native uncompressed, but sometimes it's slower. So in your testing you'll see if it's faster, but there can also be speed benefits to go ahead and compress. As a matter of fact, most of the time what you'll find is the compression process itself takes a little bit longer than just a native uncompressed backup, but the savings that you find, or the savings that you get with it, are worth it. Again, it's a payoff between how long it takes, how much drive space you have, and how much you need to be saving by using this compression. If you use, excuse me, SQL 2008 eventually they had native compression built into SQL Server, starting with, actually was if I believe I'm correct, it was 2008 Enterprise originally, and then since it has been reverted back to any 2008 or 2008 R2 or 2012 Standard or Enterprise. So those all have compression, backup compression built in. Data compression, no. Backup compression, yes, on the standard editions. It is relatively simple. Native compression is relatively simple because it doesn't offer any options as far as compression ratios. It doesn't say, okay, you have 10 different levels of compression like some of the third-party tools do, but it's very good, very handy. It's built in. No need to worry about licenses. No need to worry about if you're on a tight budget, you go ahead and use the native compression and it works just great. Again, the two problems with native compression that's built into SQL Server are, again, no allowances for using different compression levels, and the other one is, of course, you can't encrypt. You can't encrypt your database backups with native compression. So at this point, you have to use a third-party tool to be able to do that. And there are plenty of third-party tools out there. Redgate makes them. Idera makes them. I think Redgate makes a couple different, SQL Safe and Hyperback and Lightspeed by Quest. There are all kinds of tools. I've used Hyperback at one previous job I was at. I've used Lightspeed at another one. Actually, Hyperback is what we're using at the current place I'm at for those servers that are not yet on 2008. Excuse me. Very good tools, very wonderful. I don't mean to disparage them in any way, because they do offer many other benefits that native compression doesn't use. So if your organization can afford them and can afford to deploy them across its servers, then it's certainly worth taking a look at some of the advantages that they bring to the table. And we'll leave it at that. Backup types. All right, now we're getting to the juicy stuff here. What kind of backup types are there? What are we doing here? I'm sorry. How about that? I went all the way back. Backup types. All right. Well, the first and most obvious type, and one that most people are obviously familiar with, is going to be your full backup type. It includes a full backup, whether it's compressed or not compressed, contains a full copy, 100%, obviously, of all the data. As well, a lot of people don't realize this, but of course it also contains a copy of the current transaction log. The backup doesn't copy empty space that's in your databases on those pages. So what it's going to be itself, if it's not compressed, slightly smaller than the actual database itself, because that database itself contains empty space on the pages, whereas the backups don't. But also understand that the copy that does make sure you understand that the database full backup will contain a full copy of the data and the current transaction log. Now, the reason I emphasize that second half is that means your full database backup will be smaller if there was a transaction log taken right previous to the full. So if you take a transaction log backup, it empties out, it backs up that T-log, truncates it, and then if you take a full relatively soon after that, your transaction log hasn't had a chance to grow up too much. So keep that in mind as your strategy. You might want to schedule a T-log backup right before your full, if, say, for instance, your full is on a daily basis. Another thing to realize about your full backups, they include the permissions and the logins that are associated with each individual database. But that doesn't include is the logins. The logins are server-level objects, as you probably know. Since the logins are server-level objects and they are contained in the master database, there's another reason why you want to make sure you back up your master database. But understand that in itself, if you go ahead and restore a backup on a different server that has all the permissions and the users from the original server, you go and restore it on a different server, well then those users are going to be orphaned, and we won't get into all that right now, but understand that they won't have appropriate logins to match up with. So for that very reason, you need to make sure that you script out these logins from the master database. And we'll leave it at that. Another important thing to realize about full backups is that transactions doesn't put a stop on your database. Transactions can and do occur while the backup is being taken. For all intents and purposes, what happens is it records the date in some system file. Then the backup is taken, the full backup is taken. Then right after the full backup is taken, any transactions that have been recorded since that date since the timestamp at the very beginning are appended on. At that point, the file is considered closed and sent over, and the new point in time, which is that second point in time after the backup is done, is recorded into the logs. So enough. Basically what that means is, again, you can have transactions occurring. Backups don't stop your database. So if you need to schedule a backup or transaction log during the day, a transaction log backup during the day, don't be afraid to do it because you're worried about it shutting down your database while it's going on. The second type of backup that we'll talk about is a differential. I'm going to go downwards in the order of granularity here. Differential is actually very clever, and a lot of people, oops, did this again. Look at that, I did it again, didn't I? Because I'm rolling my mouse wheel. Anyway, I'm just going to leave it at that. The differential. A differential backup only records changes. This is the important part. Only records changes since the last full backup. All right? Whereas a transaction log backup will record all changes since the last transaction log or differential. The differential only goes back since the last full. Now it's important to realize, because if you take a full backup on Sunday night and the differential on Monday night and differential on Tuesday night, that Tuesday night differential is going to go ahead and it's going to contain all the changes that you have in your Monday one, making your Monday one relatively useless, not useless, but less useful. So if you ever needed to go back and restore to Tuesday afternoon, of course you would go ahead and restore that full, and then you would go ahead and restore that second differential, and then of course any transaction logs that happened after it. So the differentials are really good because they're much smaller than fulls. They run much quicker. They can be taken, and thus they can be taken much more frequently. But the problem is that the issue is that has to be taken into account is that because differentials are only record all changes since the last full, that they increase in size and they continue to increase in size until the next full is taken. So if you take a full once a week and then differentials 6 nights a week, remember those differentials are going to increase in size every single night, and the one right prior, that 6th one, is going to might be quite large. Excuse me, something just to keep in mind if that's the strategy that you go towards. But the good thing about differentials is, and I'll show you some little math a little bit later, although we're running out of time here, that the differentials allow you to reduce the number of log backups that you actually have to restore in case of emergency. I'll show you some math about that later. Log backups, go ahead and backup all the transactions that are in the log, and then of course it truncates the log, and the log backups are only done when it's in the full recovery mode. It allows for the narrowest point in time performance, allowing you to go ahead and say, hey, this is the closest amount of time that I can recover back to. I took a transaction log backup 15 minutes ago, and now the most amount of data that I'm going to lose is 15 minutes. So transaction log backups afford you the narrowest point in time recovery situation. And then real quickly, file group, there's something called file and file group backups, which allow you to go ahead and back up individual files or file groups. This is used mostly in very large databases, data warehouses. It spreads the backups over time and allows the maintenance to be a little bit more creative. For instance, it backups you could have a plan where it backs up the file groups that get a lot of activity on a more often basis than those file groups that are going ahead and holding old archived data, and they get backed up less because they don't change as much. So you can become very creative using file and file group backups. And the last one I want to mention real quick is a copy-only database backup. Copy-only is a full backup that it does the same thing. It creates a copy of a full backup of both the current data as well as the current transaction log. But what it doesn't do, it doesn't do anything in the recovery chain. Whereas if you normally take a full backup, it goes ahead and records it in the tables and says, okay, this is where the chain it goes through. In this case, it only makes a copy of the data and allows you to go ahead and use that without disrupting the chain that goes backwards into being able to recover. I hope that made sense the way I tried to explain that there. Okay, we actually took quarter till. What different ways can we go ahead and I'm going to move through this real quick now, actually, because I want to get to the demo part of it, which is the really cool. I don't want to go over 12 o'clock. So methodologies. Well, we can use Management Studio to go ahead and right-click and do a database backup. Obviously, that's the traditional way, but that is not someplace that's usually used for a single, one-off kind of backup. Hey, I need a backup done real quick. You right-click it and you go through all the options and you go ahead and take that backup. Maintenance plans. Many of you probably schedule your backups because maintenance plans are a very easy, convenient way to go ahead and schedule your backups to happen on a nightly basis, and you can integrate them with consistency checks and fragmentation checks and that kind of thing. So maintenance plans are nice but have a lot of problems when it comes to new databases or read-only databases, and when they stop and they hold it. Sometimes they don't interact with your backup compression software very well. I have lots of experiences with that in my current job. So maintenance plans are very nice and convenient, and they're readable, but have a lot of inherent problems when it comes to logging, and it has problems when it comes to they get hung up that sometimes. So use them for, like I said, for ease's sake, or for basic, very, very basic plans, but anything more complicated, you're going to have to come up with a better solution. Excuse me. If you felt like copying this down, this is the page. This is the MSDN page where it shows all the options on the backup database command. You can take a full backup. This is your very, very basic. If you want to take a full backup database, here's your name, and then here's your destination. That's the most basic. You can take a full backup with only that T-SQL right there. You can take a log backup with just that. You can take a differential here and a file group backup. When you go to this, if you were to go to this page right here, an MSDN, about 50 different parameters or different options that you can put after this backup database statement. I certainly don't have the the time to go through them all, but go ahead and take a look at the backup command there on MSDN, and you'll see the myriad of different options that you have as far as taking your backup. All right, planning. How do you plan for them? Again, this is I thought this picture was kind of funny. Some shopping center where they just, in case plan A doesn't work, I guess plan B, huh? Who's going to develop it? This was relative to making your backup plan. You got to the organization or management is going to have to decide give some individual, a person, a primary responsibility, or a group, primary responsibility for developing the plan. And this is a complex process. It's not something that's done in a bubble inside the IT department. This is something where they have to go and talk to the business. They have to go and establish the RTOs, the RPOs, know the data, know how often the data changes, and go in. And so these are people who have to be able to organize this and look at the entire picture. This isn't necessarily a DBA. Sometimes a DBA is, or the database developer is somebody who is more in tune and more in touch with just what's going on in their own little bubble. Sometimes the plan, the broad scope plan, is something that may be done by someone who has a broader scope of the picture of the organization. And executing. As far as the executing, well, this, and then 99% of the time, this certainly turns to the IT staff or the DBA. But this has got to be documented. Who's responsible for saying, okay, this is what we want. We want backups on a nightly basis. I want diffs on an hourly basis, and I want transaction logs every 10 minutes. All right, now, Mr. DBA or Ms. DBA, you go ahead and go and execute this plan, and I want to know how you're going to do it. So make sure it's down. When you plan on it, when you develop the plan, you need to develop who is going to execute the plan and who's going to back up the person. Who backups the guy. So you got a backup guy, and who's the guy or the gal who's going to say, okay, this guy's on vacation now I'm going to be responsible for making sure that these backups work and go through. Cover it all from the start. You won't have any worries about it later, right? Getting creative. Okay, and here's kind of a fun thing, okay? This is very important. You read a lot, you go online, and when you're trying to develop your background strategies, okay, they say best practice, take a full backup every night, 3 o'clock in the morning. That's best practice, and then people go ahead and blindly follow best practice as if it's the word. It's not, because what happens with best practice is, as good as it is, it does lack any necessary context. It doesn't say, okay, this is best practice for who? Is this best for resources, scaling back the resources? Is this best because it takes the least amount of time? Is this best because it's the easiest? Without knowing any specifics about your environment or what you're doing or what you're trying to accomplish, just to say, hey, listen, take backups every night, take a full backup every night and a transaction log every hour, and to follow that blindly makes no sense because obviously it lacks any necessary context. So I'm gonna be redundant here. Don't be a slave to best practice. Use it as a starting point. Say, okay, there's a reason for this. There's a reason why they say let's do it every night. But in my environment, these are the situations which make it a little bit better to do it a little differently. So don't be a slave to the best practice. I told you earlier about a database that only has its activity at 3 o'clock in the morning. Well, obviously, that's not a good time to go ahead and take its backups. So again, don't be a slave to the saying backups have to happen in the middle of the night. If I have a database that has all its activity in the middle of the night, well, by all means, schedule its backup in the middle of the afternoon. Spread the load out. Be creative. And don't necessarily say, hey, everywhere I've always been, they've taken their backups in the middle of the night because just because. I assume that's when business is lightest. Well, you know what? Not necessarily the truth. Frequent differentials, and I'll show you the little math here, okay? Differentials are great because they, again, one of the main benefits is they decrease the number of transaction logs that you have to recover. We'll go into 2 scenarios. Let's say in scenario number 1, and it has the math on here, okay? Take a full backup every day at midnight. I take a transaction log backup every minute, 15 minutes, and let's say my corruption happens, my emergency happens at 11:46 p.m., right? Almost 24 hours since the last full backup. So in order to recover back to my most recent transaction log, which of course, as you see, is going to be at since it's every 15 minutes, it's going to be at 11:45. So that's great because my plan was never lose more than 15 minutes. At this point, my corruption happened at 11:46. I can actually go back only 1 minute, so that's awesome. I can only lose 1 minute worth of data, if I could restore that instantly. But it's going to take some time for this restoration process to go through. The process for doing it, if you have fulls and T-logs only, is you restore the full, and then you apply all the transaction log backups in sequential order that they were taken. That makes sense. You're replaying everything that's happened to the databases since, and you're replaying them. So you take the full backup, That's the 1. You take 4 an hour for the 23 hours between last night's midnight and 11:45, so that's 23 times 4, and then 3 for 11:15, 11:30, and 11:45. That's 96 files to restore. Now, of course, obviously they can be coded and it can be done, but remember that it can be coded and it doesn't have to be 96 files done by hand, but it's going to be quite a bit of time that's going to be taken into restoring excuse me, 96 files to go ahead and get you back to 11:45. Let's say as an alternate plan you take a full at midnight and you take differentials every hour and you take transaction log backups every 15 minutes. And then your corruption happens at 11:46. Well, then you have 1 full backup, then you recover, then actually this is not even correct. This math is completely wrong. I don't need 23 differentials. I just need the 11 o'clock differential. So my answer is not 27. It's 1 plus 1 plus 3, and it goes 5. So it's 96 files versus 5. I was wrong with this. I only need to restore the full backup from last night, the last differential that was taken at 11 p.m., right? Now I'm caught up to 11 p.m. because it's all changes that happened between the last full and that differential. So now I'm caught up to 11. Then I take 3 transaction logs. Then I restore 3 transaction logs, the ones at 11:15, 11:30, 11:45. So it's 5. Obviously, ignore this 27. So in this situation, because what I've done is I have certainly increased my drive space requirements because I'm taking hourly differentials. But what I haven't done, what I've done is I've greatly reduced the amount of time that it's going to take me to recover, because instead of 96 files to recover, I only have to recover 5. Quite a bit of difference. So differentials, again, will allow you to greatly reduce the number of files, the number of transaction logs you need to recover, but they increase your space requirements. So if you have the space requirements, implementing a differentials in between your fulls and your transaction logs is a wonderful, wonderful plan. All right, now we have 10 minutes to go. I want to go to a demo real quick. You can, in MSDB, there contains a whole bunch of tables that have all the information about your backups. I'm not going to go into all these right now. You can go ahead and ponder through this. I'll post this on my website a little bit later in case you want to look at. Basically, these are all tables that contain rows for all your backup sets and your backup information, your marks, transactions, and suspect pages, and all that kind of stuff. So these all have to do with your backup, and they are in your system database, MSDB. Another reason why you want to back up that database on a daily basis. Oh, now my final part, because I have about 8 minutes left to go. Okay, I told you I was going to mention some scripts. Ola Halland, and I don't know if I'm pronouncing his name correctly. If you're not familiar with these, I think it's a wonderful thing. I make absolutely this has no financial gain to me. I want to make sure everybody understands that. I don't pimp these for a dime every time somebody downloads them. These are 100% free. Ola has given them away 100% free since 2007, I believe, and it is a complete maintenance solution that works not just for backups, but it also does integrity checks, your DBCC, check DBs, those kind of things on an automated basis, but it also can automate and customize your index optimization routines as well to get the fragmentation away from your indexes. But it's a wonderful option for going ahead and taking care of your database objects. I'm going to switch over real quick to Management Studio. And I'm going to do a real, since I am almost out of time, I'm going to do a real quick demo of it. The maintenance solution, what happens is if you download it, let me show you where the page here. This is what the main page looks like here. I hope you're seeing this. This is Ola's main page. If you go ahead and click this right here, this maintenance solution.sql, you do them individually, but it's best just to get them all at once. You go ahead and run this, and you go ahead and open that, and this is what comes out. You run this, and it go ahead installs it goes ahead and installs objects in your master database. Unfortunately, very odd. Because I'm on SQL Express, I can't look at the tables. But trust me, I can look at the tables because it does install a command log, a logging table. But what I can see is I can see that it does install 4 store procedures in your master database. And there are a couple things you can change here. Just when you do the installation, you can change where you put it by default. If you don't want it to create the jobs, which I don't because I'm on SQL Express, doesn't have a SQL Server agent, so I don't want it to create any jobs. I don't want it to mess up doing that. You can define the default backup when you do it at the beginning and some of the other things. Suffice to say that when you run this, you get these 4 things. Now we're going to look at this one in particular right now because it's awesome. All you have to do is run this store procedure and provide there's one mandatory, and then all the rest of these are all optional parameters. I'm going to go over them really quick. And what you do is you go ahead and you develop a command just as simple as this, which says backup my user databases. I want a full backup. This is where I want it to go, and I want it to log I want it to log. This is a very simple thing. If you schedule this command in the SQL agent for 3 o'clock in the morning, that's all it takes. No messing with maintenance plans, no messing with there's a bunch of other little parameters that you can add in here and that you will want to add in here. But for the most purposes, all it takes, all you do is just you tell it what databases, whether it's all, and I'll go into that. I'll show you that in a second, how the flexibility and how awesome it is. Okay. This should only take a second, and that's all it takes to go ahead and back up the database. It takes about 17 seconds. It takes a full backup since all databases. I only have 2 databases on this server. I have AdventureWorks DW 2012 and one called TG Test. AdventureWorks is in the simple recovery model. So it did complete the full backup. Obviously, in the simple recovery model, full backups happen. TG Test is in the full recovery model, so obviously a full backup will work as well. That's all it took to go ahead and back up, and then creates folder structures with a full backup. Boom, right there. It's a wonderful thing. It does all that without having to create the folder structures. The script does all that. I'm going to just go ahead and simulate some database activity, and I'll show you what happens in here. So I'm going to go ahead and update some rows in this table, and this is in the TG test table, which is in the full recovery model. So being it's in the full recovery model, I'm going to show some examples how quickly and easily we can take differentials and transaction log backups. So now I'm going to take a differential. This is all saying user databases, all my user databases that I can take differentials on. Go ahead and take it, put it in the same way. I'm going to log it to my login table. This should take only a couple seconds to do. Boom, that's how quick it's done. And all the output there, you can see what it does as well. All the stuff goes into this table that you've been logging. Let's simulate some more database activity. Cool. Now let's take a log backup. Again, same thing. All I've done is change the log. So when I want to schedule my log backups for an hour, create a job with a SQL Server agent, paste this little job in there, schedule for every 15 minutes, and boom, now you've got logs taken every 15 minutes. Also notice here that this is a simple recovery. AdventureWorks DW 2012 in the simple recovery mode, because it's going to ignore it, and it's not going to obviously be able to take a log backup, transaction log backup, being that's in the simple recovery mode. So it ignores it. It's very smart and very aware in that respect. The other one, which is the AdventureWorks one, is in the full recovery mode, so it goes ahead. I'm sorry, TG Test is, so it goes ahead and takes the log backup. Let's simulate some more database activity. Now let's take a differential. You can do all these fun things. All kinds of fun things. And then what else would I got here? Oh, let's simulate some more activities. And the reason I'm doing this multiple times is I want to show you the folder structure when it's all done. And now let's take the backup again of the log. So this simulates all your logs in between differentials, in between fulls, that kind of thing. And now let's show you what the folder structure looks like. This is all done automatically for you here. So in the backup folder, which you put down as your default location, or the location inside the script here, right there, it creates a folder for the name of the server. In case, of course, you have a CIF share and you back up multiple servers to the same place, it separates them by its own folder. Obviously, this is the name of this server. In AdventureWorks, it only could take fulls and diffs because it's in the simple recovery mode. It couldn't take transaction log backups. You can see the full that we took. You can see the 2 diffs that we took. In TG Test, which is the one which we can see all kinds of. We took 3 different kinds of backups. You'll see also an example of, well, unfortunately, I didn't simulate enough activity to increase the size of the database like I wanted to. But in normal situations, you'd see the differentials of obviously being larger because you've had enough activity, and the one still goes back to the previous full. So that goes ahead and shows you that, and that's some wonderful things. Now, really quickly, I know we're out of time. What's really cool is all the different options that you have as far as how you can define what databases you want to go ahead and back up. That @databases parameter, you can use this one gives you all user databases. So I want to have a plan for user databases separately from system. That's all you got to do is put this statement in here. All system databases. There we go. That's all that takes. Here's all databases. Say I want to just do them all. You just got to do that. Say I want to do a single one. It allows the parameter just to be TG test. All I want to do is back up one database, and this is all I want to do. Say I have 30 of them on my server, and I want to back up 2 individually. That allows you to put them in a comma-separated list. So all I want to do is TG test. That's allowed. Let's say I want to do all my user databases except for one. This one needs to be backed up on a different schedule, on a different basis, or in a different way. But it's the only one on the server. I can go ahead and write user databases minus TG test, and this goes ahead and backs up everything minus, except for this one database. This is easy. This is easy, and this is easy. And this is actually even kind of easy when you use the maintenance plans. But as soon as you get into some of this stuff, you have to write custom code for it, and in maintenance plans and custom T-SQL, and it is a real pain in the tush. So if you have to do that way, if you have to do something very creative, this is by far a much better option. Go ahead. This one. So using wildcards. Let's say, for instance, all I want to do is back up in this manner. This backup is only for databases that have the word TG in it. So say I have a database, for instance, a server that shouldn't. Let's say I have a server that has both prod and dev. Well, I designate my dev databases by _dev after the name. So if I want to have a plan, a backup plan for the dev ones that's different from the ones for the production ones, I go ahead and say @databases, and then I make this _dev, something of that nature. And then it only does the ones that have that string in it. You can do the same thing. I say I want a database. I want to do all of them except for anything that has this string in it. You go ahead and do all databases except for this. Wonderful options. And again, that's just so many different options it has for you to be able to define where you want to do it. Really quickly, because it's already noon. These are some of the other parameters. Are all option, but they're awesome. Verify that are included in this one database. You can see all the options here. Verify allows you to verify the database for consistency. A very good thing to do, very appropriate if you have time. It'll give you a much better idea of whether the backups are happening properly. Cleanup time. This is almost mandatory if you don't want your backup drives, unless you have unlimited backup drives or some other methodology of purging your backup drives. You add a cleanup time, and it goes ahead and removes all files in that folder that are older than that many hours. Awesome. That's another part of the maintenance plan that's always been hard to do and hard to deal with. One parameter in Ola scripts. Compress. If you're using native compression and it's set on a server basis, you don't necessarily need this line. But if you are using, if you're not using native compression or you want to use some sort of third-party product, you want to use this line. Copy only, we talked about that, makes that copy only database that goes ahead and doesn't influence the backup chain. This is really cool. In a maintenance plan, if you have a new server and you try to take a transaction log, new database, you try to take a transaction log backup, it fails, the maintenance plan dies and hangs up. This parameter solves that problem. It says change backup type if you have that set to Y. If it cannot take a transaction log or diff, it goes ahead and takes a full. It automatically does that. How wonderful is that? That's all. That kind of custom coding in a maintenance plan on T-SQL would take a long time. It allows you to define what backup software you want to use. Say you're in an environment that has got Hyperback and Lightspeed. Well, for this backup and this particular schedule, I want to use Lightspeed for this. And here's the compression level. It allows you to define it for the backup. Allows you to add more descriptions for documentation. It allows you to encrypt it when you use the third-party software. This is very important. Logging is awesome, and I'm going to show you this in 2 seconds, and we're done. And this allows you, this command right here allows you to maybe not execute the commands, but just print them out to your screen. So if you have execute equals n, it'll print all your commands out to your screen, but it won't execute them. That's kind of nice for troubleshooting and see what you want to do. Now, last thing I want to do is when we look at this log. I had logging set to yes on all of those because I wanted to show you what the command log looks like. And this is what it is. It documents the database name. And this is all built into this script. This is so awesome. The command it took, so you can always go back and look at it and see what exactly did it run. And that's the command right there. You can see the backup data, all the backup databases, the diffs command comes out to this, and the transaction logs comes out to this. The start time, the end time, you can track those errors if they happen. And this is all just generated by this one parameter. So that being the case, I think we are done. Let me go back to my PowerPoint presentation. I know it's after 12. There we go. Yes, that was my last slide. So